Good evening, heroes and heroines, and welcome to Practising Programming in C, where we are hopefully finishing, our foray into compression. Let me just get my stuff up, as it were. I need for code. And what was it? Open, and it was MZ, wasn't it? Yeah. MZ.c, yeah, right, okay. So I will also put some music on and we can just get started. I'll just like recap where I'm up to, because we've had a weekend we've had a weekend and a bit actually, a weekend and a few days without any of this at all. So I'll have to just just recap where I'm actually up to. So I did get the Burrows-Wheeler transform done, and I managed to implement that without too much trouble. Did all the sorting, did the compare strings as well. That seemed to go alright. And then the last episode it was doing output car and eat car. And I've been thinking about this, and I'm not 100% sure that I want to use these. Excuse me. I'm gonna keep them here. I'm not gonna get rid, but I'm gonna. You know, I don't think that I don't think that I'll use them. Only because. At the moment, it feels like it's like another thing for me to think about. Like it doesn't feel like it's like simplifying the process for me. It feels like it's just another thing for me to kind of another ball for me to keep in the air, as it were. So I think rather than using that, I think I will just continue doing this sort of an idea. Oh, this is actually for the RLE, isn't it? Yeah. Did I do any of this stuff for the BWT? Yeah. So it's basically this, right? Setting the value of something, and then incrementing the pointer to that address. It's basically that idea. Here begins the BWT. Yeah, but it's basically like, it was just the RLE which was just really bamboozling me. What state is this even in at the moment? It does build. It's MZ. Does this die? It does die. Does this die? It does. And it's the BWT corpus, I believe. This doesn't die. Right, good. It also doesn't. Where was that printf? I just saw a printf somewhere. This thing. Why didn't that print off? MZ. Unless was that the? Because we've got. Who begins with BWT? Printf. Okay, right. So maybe we're just coming out. Oh, these two are going to be the two printfs. Yeah, right. I thought they were outputting the BWT bit, but it's not. So that's like it's printing out 8 characters of the in buffer. Here begins the RLE code. Okay, so at this point, let me just print F of this. The BWT decoder string is all of that lot, right? Okay. And then the next printf is printing off printfing 8 characters of that, and that looks to be about right. So yeah, so at this point the in buffer contains like, well, it's so like if I do inside, I think. So it's going to print out, yeah, it prints a lot. If I try and do this, it should fail. Oh. Oh, I'll tell you what. No, what? Shouldn't that fail? Unless, is it null terminated? But then if it's null terminated, why am I passing that size? So this is print effing down to, hang on, let's just remove the other printfs, just so I know exactly what just this one will do actually. So it's ending with an actual new line. That's interesting. Because like, if I were to do this, because it, oh sorry, I'm putting a new line there anyway, so it's like a 6E, and a 6E is it's in hex. A 6E is in N. Not 100% sure why this isn't failing. Because like, oh hang on, unless maybe it's kind of interesting actually. Like, what seems to be happening is that, well, I mean, I'm passing a size to it, so it should only printf that much, but for some reason it's like stopping after the 0A, which is a new line. Like if I just take this away, now there's no new line, but the last character is that 6E, which is in N. Right, and that N is just going to be this. That N and then no new line. So it kind of seems like what's happening is that it is I mean, like, it's going to hit the new line, and then presumably, well, actually, let's actually test it. Can I do this? I don't know that I could actually test it. I was going to say, like, step into it. CGDB. Go down to the printf. It's this one, isn't it? So if I run to there, because like in buffer, Oh, actually, yeah, I can do this. In buffer to in size -1 is going to be the n, but the one after that is going to okay, so it is a null. But I mean, my question then is like, why does it crash if I don't give it a size? Do you know what I mean? Like, if I do it like this, right, do exactly the same thing as I just did, right, so run down to that. Well, I mean, I didn't actually hit the case, but I ran. Actually, I'll tell you what, I can see it, can't I? Because in buffer at the in size -1 is the n, and that is a null, right? So printf should complete without crashing, shouldn't it? And it doesn't. I was thinking it should complete without crashing because it only goes up to the new line. Oh, sorry, it goes up to the null and then dies. Sorry, it goes up to the null and then stops printing when it hits the null. Yeah. Well, obviously that's not. Yeah, it's not really behaving in the way that I'd expect. But anyway, I mean, it's a bit of a total detour. Because it's nothing to do with the RLE part of it. So yeah, what we're doing, RLE and compression test utility, apparently. So I've got the in buffer, and I want to be, yeah, I want to be run like the encoding this in buffer. So let us nuke all of this stuff, I reckon. Really point of mine as well. RLE buffer. Right, okay, so that's just going to set that to a null. Free RLE buffer. So we're trying to malloc enough space for the RLE buffer. And if we succeed, then we continue. If not, have we actually... Yeah, I mean, by now we have actually... We have mallocked the other stuff, haven't we? So this is something that I also need to do as well. I do need to figure out a way to like have a good kind of error path. You know, like when I hit one of these P errors, there should be like a place that it goes to. Where it sort of unwinds all of the previous stuff. Because at the moment it just it just errors and returns 1. Which means that it exits the program. Yeah, it's like this one, it's mallocing the in buffer. And if that succeeds, then it continues. Otherwise it fails and it does that. Yeah, actually, I mean, if it fails, it leaves the in file open. But let's say that succeeds. If we get down here and this malloc fails, then this it just prints the error message out and returns 1. But it doesn't do anything about freeing this previous allocation. So that's something that I will have to try and figure out how to do. Not now because I'm doing the RLE, but that is something I'll have to try and figure out a good strategy for that. But yeah, like, let's see about this. So to do this RLE, I want to be looping over everything in the in buffer. So I've got the RLE pointer, and I'm going to be incrementing the RLE oh no, I'm going to be incrementing the in pointer. So it's like, yeah. So it is going to be, while the in pointer, take away the in buffer, is less than the in size. I want to do some stuff, and at the end of that, increment the in pointer, sorry. Let's just compile this. Right. Let's just take away the printf at the moment. We don't need to see that. We need some tokens, don't we? The in pointer. Do I have an in pointer? Oh yeah, the in pointer's there. So the in pointer is set at the start of the in buffer, and the RLE pointer is set at the start of the RLE buffer. Right, so they're set up together. So I want to say I kind of want to say the in pointer, the value at the in pointer. Can I do this? The value at the the value at the RLE pointer rather plus plus is going to be equal to the value at the in pointer plus plus. Let me just see if I can do this. Okay, I can do that. So let's just actually step into this and see what this is doing. Just to refresh my memory as to what any of this does. So I need to run to there, and step over there. And now let us just print off the... can I just print the RLE buffer like this? I wonder. Where am I? So the RLE buffer contains an N. I'll tell you what, actually. Let us quit, and let's just put this line in here. And then let's run into the loop. So what is the in buffer at this point? It's going to be the N, isn't it? So if I continue, and then I do this again, oh, it still contains just the N. In buffer. It's not the in buffer. It's actually the RLE buffer that I want to be looking at. So that's going to be the first value. Can I NH, right, okay, this is what I'm talking about. This is what I'm wanting to see. NHE, right. And the in buffer is NHH. Wow, that's interesting. Oh, it's because I'm incrementing the in pointer down here. Yeah. So I don't want to be doing that there. Excuse me while I blow my nose. Yeah. So so whenever I set that, whenever I move the hourly, let's just try doing this. Right, I'm going to set this outside here. Right. And then what I want to be doing is I want to be seeing if the value at the RLE pointer minus, or like if the this was the -1 thing, wasn't it? It's interesting though, because I don't remember. Oh, because I had a token, didn't I? Previously I had the token, so that's why I didn't have the -1 all those weeks ago. Yeah, it's like if the value at this is equal to the value of the end pointer, then I want to increment a counter. If it's equal to that, well, hang on a minute, it's like we want to and it's also because the count was going to be like it's the 128 range, isn't it? We were saying. Because basically what we're saying is it's gonna kind of take up the upper edge of the car. What's that complaining about? Counter. Sorry. Yeah. Implicit conversion. Right. Okay. Is it like this? No. Oh, we need to do unsigned. Right. So basically what we're saying is when it equals 128, it's like it's like the actual value is counter minus 127. Like the actual number. Although we don't need to care about that at the moment, it's really for the decoder. It's the decoder side that needs to remember that. If that happens, then we need to implement the counter. And I was also doing this interesting thing, well, interesting to me, where I set the value at the hourly pointer. Without actually incrementing the pointer itself. Yeah, I just do feel like that's a reasonable thing to do. You know, I wanted to do this, basically. So yeah, if they are equal, else we want to say that the value at hourly pointer is equal to the value of the in pointer. Hang on a second. Maybe this was where I was getting a bit muddled up. You know, not incrementing the right thing. And probably this is why I probably was getting muddled up with the incrementing, and that's probably why Saf recommended that I do the those functions. You know, because it's like either way, I do want to be iterating through the in buffer. The thing is though, right, if they stop matching, this is probably where the discrepancy is coming in. Yeah, it probably would be easier if I do have a separate token, just to guard against all this craziness. So rather than doing that, or actually rather than doing that, you actually say token yeah, these can all go together, I think. Although, yeah, let's put them like that. So I've got the token and it's like if the token is equal to the in pointer, then we want to increment the counter. Otherwise, if the token stops matching, then we want to say that the value at the hourly pointer is equal to token. But hang on a minute. Why do we actually set the value of the? You know, when do we write the counter? Else, you probably need to do an if, don't you? Like, if the counter is greater than, say, 1 or greater than 0, you want to set the value of the hourly pointer plus plus to be equal to the counter, and then you want to set the counter to be back to 128. Wasn't I doing something else here as well? Like setting the token to be something. You know, wasn't it just like you then set the token to be equal to the value of the in pointer? The in pointer plus plus, maybe. Otherwise, you want to set this Is that right? Yeah, that does seem right to me. You know, if the counter is greater than 0, then we set hourly pointer plus plus to be equal to token, or you set hourly pointer plus to be equal to. And if we haven't entered the... Oh, if they're not equal. Oh, hang on a second. No, that can't be... if token is the same, then we need to increment, otherwise... If they're the same, we need to increment the counter and do nothing else. If they're not the same, we're seeing... Oh, actually, this might be reasonable. If the counter is greater than 0, well, it's greater than 128, 27 rather. Token is equal to in pointer. The hourly pointer plus was equal to the token, the counter rather, and we set the counter back to 128. And it should actually be if it's greater than 128, shouldn't it? because it's always going to be, it's always going to be. Yeah, it's always going to be up to at least 128. If the counter goes, it's 128. Let's just see what this does. Right, it doesn't die. That's nice. Okay. Let's just try printing out the RLE buffer. It's kind of handy that I've got that there. And, yeah. Inside, hang on a minute. What's this? I've only come to the end pointer, RLE pointer. It should really be the value at the RLE pointer. The value of the RLE pointer is equal to a null. And I want to print f the RLE buffer up to RLE pointer take away RLE buffer. Field precision should have type int. Yeah. What are... yeah, I'm not 100% sure why it doesn't want that. Because I've done like in pointer take away in buffer up there. RLE pointer take away RLE buffer is the same sort of a construction. See what it does. It doesn't die, which is kind of nice. Yeah, it's going to be one of those. And it's going to be the in size, and it's the in buffer. So that's suggesting to me that it is iterating over the right number of things, potentially. And it's just, it's managed to run length encode, you know, like this amount of characters. It's just not setting the token correctly. I need to do that each time with the loot, don't I? Yeah, That's all it is, isn't it? Possibly. Where am I encoded? Yeah, I'm encoded, imported down there. And actually, what's this doing? Tokens equal to that. So, right. If tokens equal to the in pointer. Token is equal to in pointer. Otherwise, right. Yeah, it's not actually this, is it? It's, sorry. If the token is equal to the value of the in pointer, we want to increment the counter. Otherwise, let's do this. Right. Yeah, okay, so what I'm basically doing is well, hang on a minute. Yeah, right. I think I need to be doing this. So I'm doing that in both cases. Right, let's just see what this does. So this looks almost correct, but not quite, because you've got an NH. Let's just pipe that actually. So we've got, where's the previous printf? So, right, it's this one here. So we've got NH, and then we've got 81. And then an E. So an 81. What's that? Where's the hex? Right. Yeah, okay, so 81 is off the scale, which is what I want. The only trouble is that I'm not outputting the... I'm not outputting this A. So let's just check out what this is actually doing. Oh, I suppose we can step through it. Gosh, I did that before as well. Like, dash, dash, space. So I want to do the RLA stuff. It means the RLA encoder rather. So let's just jump down to the loop, run to there. And what is the issue here? It's never setting the token correctly. Well, I mean, it's not always setting the token correctly, right? Token is currently n. So if the token is equal to the value of the in pointer, which it isn't. So jump down here. And it checks if the counter is greater than that, which it isn't either. It's now going to set the token to the next value. So it was an N. It's now an H. And it's going to set the hourly pointer plus plus to be equal to the token. So it's going to be equal to that H. And the value of hourly pointer should be null at the moment. Should be nonsense, yeah. But the value of this minus 1 should be equal to the N. Yeah, right. Wow. These small victories. Always good to understand what's going on. So hourly pointer plus plus is equal to the token. Token is equal to the in pointer. Yeah, that's correct, isn't it? And it did increment it, so that is set that to the H. We've incremented the in pointer. What is token? So yeah, token, this is where we're going to be testing if it's the same. It is the same, so it's incremented the counter. And then we said else, otherwise, right, I've incremented the in pointer now. So now we're going back round. We're saying if the token is equal to the in pointer, and I presume this is going to fail this. If the counter is greater than 128, which it is, it's going to go in here. Oh! Hang on. What is the hourly buff at the moment? That's NH. Oh, and it's also not that. It's how do I see this? It's the in buffer, isn't it? Right. So it's NHH AE, and the issue was it wasn't printing the A. So at the moment we've got counter is greater than that, so we're going to enter this thing. Token is equal to the H. What's the value input again? That's an A. Right, so this is where we need to be. Setting the token to be equal to the A, right? Put the counter into the hourly pointer, and the hourly pointer is currently what should it currently be? It should currently be an 8, shouldn't it? So I'm basically saying here that there's a run of H's, basically is what we're saying. So we're outputting the counter and resetting the counter. And because we've entered this loop, we're not entering the other loop. We're incrementing in pointer. We're incrementing in pointer. Well, the token is A. So these aren't going to be equal, are they? They're not equal. And then the counter isn't that. Ah, right. I'm setting the token to be equal to the input, right. That's unfortunate. Well, hang on a minute, if I just reverse those guys, will that just fix it? No, it won't. Because I'm now not outputting the... Ah, damn it. What was the issue? Didn't I say something about them both doing the same thing? They're both doing this token is equal to that. Let me just see what happens if I... Oops. NH... No, that's not right again. Damn it. I'm sure I didn't have... No, last time I'm sure I didn't have another else. Oh right, I'm sure I didn't have another if branch, yeah. So I'm not sure why I have done this. Well, let's just see if that is greater than that. Oh yeah, it's because yeah, before I was only toggling, wasn't I? I didn't need to actually output the actual content of the previous thing. I just needed to output the counter. So maybe this is correct. So it was previously, it wasn't like that, it was like this, wasn't it? And the issue was when I came down here. It was saying the token. It's not the same. If they don't match, then we want to be outputting either the counter or we want to be setting I kind of feel like that's a bit more correct. Token equals to the in pointer. Token equals to the in pointer. Down here. If the token is equal to the in pointer, then we increment the counter. Otherwise, if the token does not equal to the in pointer, then we see if the counter is greater than 128. And if it is, then we know that we have a run. outputting literals basically. So if we have a run, we want to be outputting we want to be setting this, right? And resetting the counter. You know, this is the kind of important thing. So this is in the case that they've stopped matching. They've stopped matching. Hang on a minute. Yeah. That's not much. We do want to. I presume we do want to do that. Or maybe we don't actually. See what happens if we don't. NN8G, right. That's interesting actually. Why is it... Hang on a minute. Why is it not realising that there's two ends? If they match, increment the counter. I think doing it with a single while loop, one card time might make it harder than it needs to be. Single while loop, one card time. With a single while loop. Okay, let's think about this. Oh right. So you might have one loop for literals and one loop for runs, maybe. So like, I think I see. So we have like the outer loop, and then we have like an inner loop while that's still matching. So instead of this being an if, this is like a while. While they're matching. And while they don't match. Insofar as we consider having the outer loop output the literal, then an inner loop to see if it is a run, and if so output the counter. The outer loop output the literal. And if it is a run, then the inner loop skips forward a bit. And the outer loop output the literal, okay. So the outer loop output is literal. So that means what is it? The hourly pointer plus plus to be equal to the value at the in pointer yeah, let's just stick with this for now, just so we've only got like the one increment. And the inner loop probably needs to do this test as well, actually. So the outer loop is output in the literal. Maybe misunderstanding the scheme I'm going for. Well, basically what I'm trying to do is I'm trying to say, so like for, let me just print out my output. Oh, I don't know if this is going to do anything actually. No. Damn it. Just nuke this a moment. Dear. Yeah. Well, let's just say, for example, that we've got we've got some stuff, right? Basically, what I'm trying to do is to make it output the A, and then test if it's the same, and then if it is, then we're going to increment the counter, and we're saying that the counter is 128. But the actual value is going to be that, take away 127. Although I might be a bit off by 1 here. Possibly. But essentially it'd be like, so 128 is equal to 1. And then, so for this, it's going to be like, how many A's is there? 1, 2, 3, 4, 5, 6. So it's going to be equal to, so 134. You want to swing for a little because you, yeah, that's right, yeah. Yeah, that was a SAF's idea. Just do this. Yeah, that's all it is basically. So this it should output A30 120, which goes what is Vasarely still hold? Okay. And then this should be like 129 or something. So that's the output that I'm expecting from this. Yeah. So so the outer loop is outputting the literals, but it does need to check if they if they match. So if they don't match, then we want to be. We actually want to do this after the other while loop, I reckon. So while they are the same, we want to increment the counter. And it's like here, then we, outside of this what loop, then we'd say the inner loop skips forward a bit. Oh, those things might be useful. Yeah. Oh wow, this isn't even in a scope. Okay. So yeah. Again something So the outer loop was outputting the literals. And then the inner loop, see if it doesn't run. And if so, output the counter. If it doesn't run, so if loop it through the buffer. So into the buffer. Enter the buffer. And we do want to do like RLE pointer plus plus is equal to the end pointer. Well, let's just not do the plus plus for now. We want to do this. Then let's enter the enter a loop. Well, enter the buffer. So if we were to do this, it will just fill up the whole, it'll just copy the whole thing across. But at this point, we want to see if we are a run, test if we have a run. do I, oh, I can't actually. Okay. So at each iteration of the outer loop, we just need to copy the literal over. After that, we look ahead to see if characters match the one we just copied, and if so, we notice a run. We keep going until we find a character that is not the same. At this point, we output the count of equal cards plus 128. Then we let the next outer loop iteration deal with the new car. Yeah. So let's do it in that order. Well, I know what that's doing. Out to literal. Look and see if the characters match the one we just copied. So yeah, if the new value at in pointer is equal to the thing we previously copied, this is a loop, isn't it? So while that, oh, actually no, it should be. It probably should be. If that is, then we encode the counter. If it is, then we want to do like a while. While it's the same increment the counter. After that, we look ahead to see if characters match. And if so, we notice a run. So if they match, this is a run. Right. While this, we want to say increment the counter and then test. Right, yeah. I suppose. If the value at the end pointer does not equal to the value at the so we're incrementing the yeah, we should be incrementing the in pointer, I think, all the time. And we do want to be testing also this. Because I don't want to step off the end of the buffer. Is that right? Increment the counter. Hourly pointer hasn't incremented. So this is still the same test. Then we want to set the hourly pointer, the value of the hourly pointer plus plus to be equal to the counter. And then we want to set the counter back to 128. Does that build? It does. Gosh, is that all it is? I'm sure this is going to not... It's not going to succeed. NHE. It's the same thing again. Right, okay, so I'm just iterating. I'm incrementing something incorrectly. Incrementing probably the in pointer, incrementing too many times. Mind you, I've got two O's here. I've got two E's here. Really, but interesting there's no run, yeah. Wow. If the absolute did no incrementing. Oh, okay. No incrementing at all, okay. Possibly. Well, the influences. I do need to be testing this still, I'm sure. If it's a run, we want to do counter plus plus. We want to do counter plus plus. And we want to increment the in pointer, don't we? Oh no, because I'm incrementing the in pointer there, aren't I? Yeah, that's true, yeah. Yeah, because it's no longer that. So what's the test? Oh, the test should have been, it's if the count is greater than 128. That's what the test should have been. Ah, right. If it's greater than that, then we do this. Otherwise, well, hang on a minute. Well, it's the same. No, we know that the count is going to be equal to that, greater than that as well. Because it's got to be. Dearie me. Just see what this does. Right. So I'm never incrementing the hourly point. Well, I am incrementing it here, aren't I? What is that outputting? When no one noticed false. What was it? It was saying it was saying the opposite of this, wasn't it? It was saying let's just undo it. Yeah, if the value in pointer does not equal that. Well, do we though? Because because we've incremented the in pointer here. We want to increase the counter by 1 for each character along that is equal to the original one. Then when we have done all that, we'll write the counter. It does, yeah. Yeah, exactly. Yeah. Oh, hang on a minute. That's what's happening here. Oh, it's a run. So... Right, yeah. Well, it's the same. Counter plus plus. And then when it's no longer the same, we want to flush the counter into the hourly pointer. Which kind of suggests doing it down there. But that wouldn't be right, because then it would do it every time. Actually, can you do like a while that? Else? So it kind of suggests to me that like you want to do, if they match, so while going through there we're going to do that, and if they match then we want to do while they still match. If the value of this 1 is equal to the value of the in pointer, then we enter the loop. Then we do all of this, and once this ends, then we say that the value of the hourly pointer it's all this stuff, isn't it? It's just this bit. Come out of the loop and do that. So, right, yeah, rather than doing any of that, it's just this, isn't it? Encode the counter. Pointer, in pointer is incrementing. So I've lost an increment here. Have I got my scopes a bit messed up here? What is all this? Oh, that's after the loop, isn't it? So that should be one there, I think. Point incrementing here. If they match, then we increment thing. But if they don't match, I do need to increment. Surely. You know, like, probably both actually. Oh no, because I'm incrementing that there. We could do the counteracting outside the inner loop with the right condition. Oh, blimey. Gosh. Oh, right. If so, we do the if the counter is greater than 128 outside the inner loop. Ah, I see. That seems simple. I'm going to import there. And we're setting the literal there. Let's just see what this does. So it looks to me like it's outputting a bit too much. I just need to take care of how the points are incremented. So we have 3 instances of pointers being incremented. We've got this one here, this one here, and this one down here. So we're going to come into the loop, and we're going to set the value of the hourly pointer to be equal to the value of the in pointer. And we're going to say, while the in pointer, so it's while the value of the current in pointer is equal to the next hourly pointer, which doesn't seem right to me. I do feel like why do I feel like I want to be incrementing before? Yeah, I'm like saying the current in pointer is equal to the next value of that, which isn't at all correct. It should be the other way around, right? But I can't test the just need to take care of how the points are incremented. Introducing back the token variable might help. Yeah. Let's do that. So so the value of hourly point is equal to, well, actually it shouldn't be equal to that at all. It should be it should be equal to the token. This is a run. Counter plus plus. So this seems to be reasonable because we're testing against the token. So coming into the loop, I was saying that the card token is equal to the value of the in pointer. But we're not incrementing the in pointer. And we're straight up setting the value of the hourly pointer, which is at the start of the hourly buffer, to be equal to the token. So this is gonna fail. Wait. I just do feel like I want to be doing that. Yeah, so it sets it and then it moves on. And then I come into this loop and I want to be testing. Like the in point having moved on against the token. And if they match, then we increment the counter and increment the in pointer. But if they don't match, or rather, if so once they stop matching, if the count is greater than 128, we set the value of the hourly pointer plus plus to be equal to the if you move the plus plus of the inner loop to its end. Ah, right. So the inner loop is this bit, isn't it? Okay. Let's see what this does. I've got too many hourly pointer plus pluses here, I think. Why did that make a difference? Initial token, right. That might need to do when I set the... Ah, right. When I set the token. Up here. Otherwise the if counter greater than 128 bit. Ah, right. Yeah. Ah, okay. So that could have been the busted bit there, maybe. Gosh. What's this actually outputting? What am I printfing? I'm printfing two lots of stuff. So NH. Don't know what would crash. Let's try. So what was I saying? It was like, yeah, I don't know why that was crash either, because hang on a minute, let me just throw that over somewhere. Change it back and look at the A7 message. That's located 0 bytes to the right of 62 byte region. So 62 byte region is probably my in buffer. Is that right? Heap buffer overflow, shadow bytes around the boogie address. To read one back past the end, yeah. First, the question is where that read is occurring though. Insofar as I spotted it. You saw the chicken in a while loop. Oh right. Oh I see. Right. Oh wow. Ah yeah, I do usually do them in that order actually. Right. Oh. Is this correct? Undo whatever that was. I think you're talking about what I did undo. So there are no two things that are the same in here. Tell you what, I think you've cracked it insofar as 81, 81, 81 again. 81. Is there any runs greater than 2? Oh, there's an 82 there. So we've managed to shave off an actual character's worth of stuff there. This works before because of that short set. Right, okay. Yeah, so if it fails this, then it doesn't bother to test that. Well, this is a run. Let's just get rid of that. Let's get rid of this as well. Let's have a look at what the differences between these guys. Okay, so this seems pretty respectable, although it's not printing out the actual full length, is it? So now that I've actually performed the run length encoding, where's that? It's here. I want to be able to write it to a file, don't I? I think. Is that what the BWT is doing? BWT encode. So it doesn't. So it just passes it through the in buffer. Right. Okay. So basically, that's it, isn't it? We're saying that we've done the RLE encode, like down to here, and we need the null so that we know where to run to. Oh, wait a minute. The reason that we needed the size, it wasn't so we knew how far to increment to. It was so that we knew how much to allocate. That was the reason for the that was the reason for putting the size at the start of the RLE. So how do I do that now? Oh no, sorry, it's the original size, isn't it? It's the original in size is what I actually want to be doing. Here begins the RLE encoder. Yeah, Yeah, I feel like I need to get that original size back in. What is it? It's the hourly pointer, isn't it? It was like it was something like this, something full banana cakes. Is equal to the and they want to increment the hourly pointer by the size of an int. I'm just not marking enough space or something. Oh wow. Not sure I understand what's happening here. Because this is going to be the end, and then we've got. Why isn't it? Oh no, 6. What am I printing here? Sorry, let me just Right, yeah, it's not this bit, it's just the second bit. Right, okay, good. Phew. So it is outputting that. And then we need to... It wasn't like this, was it? I did need to treat that like a... Yeah, it's pretty close. It was like so I needed to treat this like like an int. Yeah, it's just this weird syntax which I probably can't remember. It wasn't like this, was it? No. Because I remember that you've got the pointer to an hourly pointer. And you do need to split up. I did need to put that there. The cast to int star is correct. Yeah. Cast to that is correct. This is already an int. Hourly pointer. Not just this, is it? But that's like saying that the value... Oh. No. Yeah, it's just because I do want to increment that. I shouldn't have the... Sorry. Yeah. That would every points to. Size of it. Oh. Okay. Hang on. Don't know what's happening here. So the other... Okay. Wow. Oh my life. What is happening here? What did I change? Oh, I changed the malloc, didn't I? It was previously like this. Piping CGP to... Oh, is that what I'm doing? Oh yeah. Blimey. Nice one. So is this dying? I think it's still dying. Oh, it exits normally. Hang on. I've incremented by that. Oh, hang on. Was it size of int +1? Why was that? Why does it output that weirdly though? How does it BWC? Oh no, it's MZ, isn't it? Harley pointed, so this is correct, and incremented by this is correct. Look, it says read or write, and by how many bytes. Right, okay. Yeah, I mean, like, this doesn't trigger the A sound. This will. Read of size. Oh, right, okay. Right, okay. Right of size 1 at this thread T0. So it's the stuff in blue. Change around this is remember not the most efficient method of debugging though. Yeah. Yeah, so previously... So the +1 equal... That was working, that was the right size before. So it's a right. Of size 1. This is located to the right of 60 byte region. Let's just step into it and see where it actually does die. Figure out definitively the size that should be passed to malloc. Well. Okay. So the value that it does need to hang on, it's it's the int size plus the size of an int. Yeah, that's the reason why I put 8, because it's the size of an int. And it should actually be +9 probably. You know, because +1 before was correct. But I mean the RLE. Okay, so it needs to store. You know, the worst case scenario is that it stores exactly the amount that it. Yeah, it's the worst case scenario is that it's like this, isn't it? Because side of it is actually 4. Okay. Yeah, because the worst case scenario is it's just going to output all the literals. And there was actually a null at the end, wasn't there? But I suppose technically, since I'm going to be storing the... Oh, hang on, I'm not storing that, am I? I'm not storing the size of the RLE. It's the null so it's all of the incoming stuff plus this, the size of ints, plus the null. So it's like it's just this, isn't it? I mean, it's supposed to be completely correct, so I could say like it's this. Yeah, because you've got the size of the int. Then we've got the stuff in the in buffer, and then the null at the end. So what does that give us? Probably might be this line. Oh wow. Oh, so it should be okay. All right. Yeah, I mean the issue is that it's not getting into the loop, isn't it? You know, I think it's outputting the original size. 4 bytes, and int is 4 bytes, so that means that, yeah, so that should, this should be the full size that it needs. Step through CGDB. CGDB. So we want to be probably going to the first while loop, I imagine. Well, actually, we can let's go to there. So the hourly pointer is at the beginning of the buffer, and it's going to step over here and set that to be the in size. Size of int. What's the address of the hourly pointer? That is that. And it hasn't incremented, so that is just what it is. Step over this. And the address of it is now that plus 4, which is fine. Fine with me. And then we're going to set the in pointer is equal to the in buffer. Okay. Token is equal to that. Yeah. Hourly pointer is still going to be equal to this. Just step over that and it changes, so just print hourly. So it's set it to the token and incremented. Count is equal to 128. And the input. Hang on a minute. Well, in pointer. Oh no, that's fine. This should be fine. So this should enter this loop. Oh, the token isn't set. Oh, sorry, we're going to set the token now. Ah, right. Why isn't this, Oh, right. Okay. Ah, yeah. First token right, yeah. Still not working there. Yeah, but it's also not quite there. It was so I got through all of this lot. I was down to like here, wasn't I? So run to there. What value do I print out? Printing out the contents of the RLE buffer. The size has 0 bytes printable. Ah, right, okay. Oh, God. That's probably what's happening, isn't it? Mind you, no, because I am telling it to print off this much. Yeah, for some reason before, this wasn't accepting this. Right, one buffer size instead, okay. Right, one buffer, okay. One is a file descriptor of standard. Ah, right, okay. What is the size? It's like that, isn't it? unistd.h. Ah. Okay. So that was it, wasn't it? It was just printf was just failing. So okay, this seems kind of reasonable. How long have I been going? Oh, we're going for like 2 hours and 10 minutes. Wow, okay. I'll tell you what. God. I think I will print full stop. It hits 0 byte, yeah. Alright, so I think what I'll do is I'll call it there. And tomorrow implement the actual decoder part of the RLE. Could also use fwrite from Sundero, I guess. Yeah, it's to write to a file. Yeah. Oh, actually, no, to write to standard out. Standard error rather. I'm aware to it today. I certainly have. I was kind of thinking actually of having like a fried egg before doing the stream, because for some reason I'm on a bit of a fried egg kind of binge, I suppose, at the moment, or fried egg phase. But I didn't have time for it. And I also had a bit of a nap before the stream, so I don't know. But yeah, I think I'll call it here, and then tomorrow I'll do all that stuff, do the decoder, which hopefully won't take too long. Friday. Yeah, the decoder, and then also do like the testing utility thing, and all that's going to be is like it's going to be a way to run like the BWT or the RLE. Well, actually, I mean, there won't be any value in doing BWT alone, so it'd be like running the RLE on its own, or running the RLE with the BWT, just to see like how effective the BWT part of it is. And then once I've got all that, I think I'll definitely just call this part a day. But I've just remembered actually, we have successfully done like a full BWT, and I haven't actually ticked it off on the to-do list. So before we go, let's get the notes up and let us do a full tick of the BWT. Unlimited encoding. I mean, we have got unlimited encoding now, but we haven't the decoding. So tomorrow, hopefully we'll be able to tick that off, and then we can move on. And it's not a buildable file. So yeah, thanks again for watching and for being awesomely helpful and heroic, and for being fiery, and for being insofar as what does that even mean? Insofar as this is the case. For being relative, I don't know. But anyway, yeah, thanks for everything. And until tomorrow, farewell for now.